Hello everyone, welcome back. Let's talk about another easy problem on Leetcode today. Final prices with a special discount in a shop. Leetcode 1475. In this problem, we are given an integer array of prices where value at the ith index in the prices array is the price of the ith item in a shop. There is a special discount for items in the shop. If we buy the ith item, then we will receive a discount equivalent to prices j, where j is the minimum index such that j is greater than I, that is index j appears after I, and price at jth index is less than or equal to price at ith index. Otherwise, we will not receive any discount at all. Then we should return an integer array answer where ith index in answer holds the final price we will pay for the ith item of the shop, considering this special discount. So in summary, for each element in the prices array, this problem wants us to find the smaller or equal element on the right and then apply it as a discount. For example, in example 1, we can see the first price is 8 and the first smaller element on right of it is 4. So we will get the discount of 4 for this element. So the final price that we have to pay for this is 8 minus 4, which is 4. Then we see 4, and for 4, the first smaller element on the right of it is 2. So we will get a discount of 2. So the final price we pay for it is 4 minus 2, which is 2. Then for 6, again the first element on the right, which is smaller than it, is 2. So the price for this item becomes 6 minus 2 equal to 4. Then for 2, there is no element on the right which is smaller than it. So we will not get any discount. And finally, for 3, as it is the last element, there will be no element smaller than it on the right. So final price for it remains 3. And our answer array will be 42423. Then in example 2, for the given prices array, we cannot get any discount at all because for 1, there is no element on the right of it which is smaller than it. Similarly for 2, 3, 4 and 5 because the array is in the ascending order. So the given input prices array will be our answer. Now in terms of solution, one of the naive approaches to directly implement what this problem describes. That is, we create an answer array as size of the prices array and then we can run the nested loop such that for each element, we will find the smaller element on the right of it, that is prices at jth index is less than equal to prices at ith index. And as soon as we find such element, we break out of the inner nested loop and apply the discount. If we find no such element, then the discount will be 0. Now this approach is simple, but the time complexity of this is O of n square, where n is the number of elements in the prices array. I have covered this approach in detail on my site and you can find the link in the description below. And as it is an easy problem, Leetcode accepts that answer as well. And now the question is, can we do better? And the answer is yes. As described earlier, for each element, we want to get the smaller or equal element on the right, which will act as a discount. So this problem is very similar to next greater element 2, where we want to find the first greater element on right of each element, which gives us the hint that we can actually use monotonic stack here. Also, another hint is as soon as we find the price which can be applied as a discount, that is, it is the first smaller element on the right of some elements, then we want to apply it as a discount, and this gives the impression of last in first out. So using stack is inevitable. So now coming back to our example, when we see 8, our stack is empty, so we add it to the stack. Then the next element we see is 4, which is less than 8. So this means we can actually use 4 as a discount to 8. That means we should pop out 8 from the stack, marking it as processed because we found discount value 4 for 8 and apply the discount to it. So that's how the stack operation will work. And now we have applied 4 as a discount, but 4 can also find some element on the right which can be smaller than it and can be used as a discount. So we add 4 to the stack. Then the next element we see is 6. And now when we see 6, should we pop out 4 or should we add 6 also to the stack? And the answer is we should add 6 also to the stack because 6 cannot be used as a discount for 4. But there may be some other element on the right which may be smaller or equal to 4 and 6. So in this case, we are building monotonically increasing stack. And then we see 2. So that means now 2 can be used as a discount to both 4 and 6. So we pop both of them out and apply the discount 2 to them and so on. Also, to apply the discount, we need to know the index at which we are applying it in the answer array. So we should be storing indices in the stack rather than the actual values. Now let's see this in action. Initially, let's create the answer array, which is clone of prices, assuming 0 discount, and our stack will be empty. Now we will start iterating on the prices array. First element we see is 8 and stack is empty. So we push 8's index, that is 0, onto the stack. Then the next element we see is 4 and 4 is less than 8. So 4 can be used as a discount for 8 and hence we will pop out 8 and apply the discount at 0th index. Now we will push index of 4 onto the stack because it may find some element on the right which is less than or equal to it. Then the next element we see is 6 and 6 is more than 4. This cannot act as a discount for 4. So we will push index of 6 onto the stack. Then we see 2 and 2 is less than 6. So that means 2 is the first smaller element on the right of 6 which can be used as a discount. So we will pop out 2 and give the discount of 2 at the second index. So now the top of the stack is 1 and we see that 2 is also less than 4. So this means 2 can be applied as a discount on 4 as well. So we will pop out index 1 and apply the discount at the first index. And now there are no more elements on the stack. So we will push index of 2, that is 3, onto the stack. Then the next element we see is 3 and 3 is more than 2. So it cannot be used as a discount. So we will push index of 3, that is 4, onto the stack. And now we are done with all the elements in the prices array. And our final prices will be 42423. And now we have reduced the time complexity from O of n squared to O of n because each element in the array is pushed and popped from the stack at most once. And in terms of space complexity, it will be O of n for storing the indices on the stack and also for our output answer array. So now let's jump into the code part. First, let's create answer array as clone of the prices array. Let's also create stack to keep track of indices of the prices that we have encountered. And we can use array-deck implementation for that. Now we will go through all the elements in the prices array and I here represent current index. Now while the stack is not empty and current price is less than or equal to the price at the index of the top of the stack, then current price can be used as a discount for the element at the top of the stack. So we will pop the index out of the stack and apply the discount at that index by subtracting the current price from the price at the popped index. And once we have processed all the elements larger than or equal to current element, we will push current index onto the stack. And once we are done with all the prices, we will return our answer. Now let's submit this code. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.